All right. So some key concepts in solving equations. First one, we're going to use what we call inverse operations. Okay. So inverse operations are operations that undo each other. So what undoes addition? Subtraction. What undoes multiplication? Division. Okay, so multiplication undoes division, division undoes multiplication, adding undoes subtraction, subtraction undoes adding. Okay, solving equations. Overall goal, like I said, is to isolate the variable on one side and get all your other terms to the other side. Okay, and the other terms should all be constants. What's a constant? Stays the same. Change numbers that do not change. Okay, so we get our variable terms on one side, things that can change or do change, and our constants on the other side, and that's going to allow us to eventually solve the equation. But we do that moving of one thing to one side of the equation to the other using opposite operations. Okay, so this isolation process is done by using inverse operations. Like I said, you might hear people say inverse operations. Okay. One thing I need us to understand, this gets, I get a lot of people that get this confused. You are going to do order of operations from time to time in these problems, but if you're going to take something and move it across the equal sign, then you're doing inverse operations. Okay. If I need to, let's just say, let's scroll down to one of these examples real quick that actually has this present. Like looking at this one here, okay? There is some stuff I need to do on the left-hand side all by itself first. I need to take that 2 and distribute it. Does that make sense? Once I distribute that 2, I'm going to get a 6 in there. And there's going to be a 6 minus 5 at some point on the left-hand side. I would need to combine those numbers using order of operations before I move anything over. Does that make sense? Okay, so those are the strategies that need to be used with working with these types of equations. These early ones are just focusing on trying to get all variable terms to one side and all constants to the other side. Okay, so we're using inverse operations here. So what do you guys want to do first? I'm trying to solve this equation. What do you want to do first? Subtract 2. Why that one? Okay. Okay, so you're saying that you want, you're saying 94 minus 2 is going to be easier for you than 2 minus 94. I would argue that's a good thing to do. Okay, so I'm going to subtract 2. Subtract 2. Okay, so now the 7W, I didn't do anything with that, right? And this is the idea. What does that go to? 0. So when it's 7W plus 0, we just write 7W, right? And now I have 3W plus 92. Now what are you going to do? What are you going to divide by? Okay, so remember the overall goal is all our variables to one side. So right now I still got 3W on both sides. Good. So how many W's does this give me over here? 4 W's is now equal to 92, right? Divide by 4. Is that something we can do? Now, is that the only way we could have done it? What if I had 7W plus 2 equals 3W plus 94, right? Could we have done, so you move the 2 over first, right? Can I move the 3W over first? And that math would look different, right? My work would look different than somebody that did it the first way. But it still gets you the same answer. If I would have gone this, subtract 7W, as long as I do it to both sides, I'm okay, right? And now at this situation, okay, I could do whatever I want. If I wanted to add 6 to both sides, I could. I don't know if that makes sense, but we could do it. Okay? But at this juncture, you're probably going to want to subtract 94 for both sides, right? So we get negative 92 equals negative 4w. Now you would divide by negative 4, right? Does that still give you 23 equals w? So my argument here is when I ask you, what do you want to do next, or what do you want to do first, there's usually not a wrong answer to that, okay? And I think you have to process that as a student, because I'm asking your preference, and usually people have preference. I also say he had a preference. He wanted to move the 2 over first. I have a preference. I like to move my constants first, and then move my variables second. And I like to move my variables, regardless of being plus or minus, I like to move them to the left. Okay? It's just preferences, but I understand that even though I have preferences, that doesn't mean that's set in stone. I can change them a little bit as long as I understand the overall governing concept of what you do to one side, you need to do to the other. You're going to be okay with these things. So this second one, we'll go across the top. Second one. Okay, what do you want to do first? Yeah? Okay, add 2g to both sides. That's perfectly fine. My hope is that we all understand that there's 4 things I could do first, right? 4 like logical things that make sense. Okay, I could add 2g to both sides. I could add g to both sides. I could subtract 15 from both sides or subtract 23 from both sides, right? Okay, those are the logical things. There's an infinite thing. We could add 100 to each side if we want to. That doesn't make sense, but you could. But one of the 4 logical things is to add 2g. So you get 15. What's negative g plus 2g? 1g. Subtract 15 from both sides. So it isolates our variable g and gives us 8, right? Now remember what we're doing here. Remember what g represents a solution that makes the left-hand side and the right-hand side true. Okay, it makes this a true statement here. What's 15 minus 8? 7. And this will be 23 minus 16. What's 23 minus 16? 7. The 7 equals 7. And that's what we mean by solving for a variable, solving for g, finding the solution or the value that satisfies the equation. It means it makes the equation true. No other number you choose. How many other numbers are there? Infinite. Of all those infinite values that exist out there, none of them make that original equation true other than 7. Okay? What do you want to do here? Okay, add 2c. That's what I like to do if, I said I like to move my variables to the left, but I also try to think about, what can I do to make my variables positive? Not many people like subtracting negatives, right? Okay, so if I can avoid that, I'm going to. So when I add that, I get 7c minus 9 equals 8. Now what? So we get 7c is equal to 17. And now what? $17 over 7. Divide by 7. Now here, and we'll talk about this. You want to pay attention to how Math Excel wants our answers. Okay? I'm of the preference of, like, if we were doing this on like a handwritten assessment that I gave you, like a worksheet or something like that, I'd be looking for 17 over 7. I like to leave my answers, and I like to see your answers left as improper, fully reduced fractions. For the mere fact that if I go 17 over 7, it gives me that nasty decimal, right? And at some point, to express that on my paper, I have to round it, correct? Does that make sense, everybody? So let's just say that I round that to 2.429. Let's just do that real quick. So now, just kind of explain, we had 5c minus 9 and we had 8 minus 2c, right? Okay, now I've got, in Desmos it gives me these errors here because it doesn't know what c is right now. But let's say that this 17 over 7 is c. Does that make these two things identical? Does that make sense to everybody? But if I would have rounded 17 over 7 to this, do we see that they're not identical now? Okay, so this is an approximation of the answer, but it is not the number that makes the statement or the equation true at the beginning. Does that make sense? So people always ask, well, why can't I just round? Why can't I round like the nearest whole number or nearest tenths or hundredths? That's the reason we like to leave things as fractions. It's the reason we like to leave, and there's other types of numbers. When we start talking about radicals and stuff like that, those will be the same way. And we like to leave them this way, okay? And think about this. Inherently, humans are lazy people, right? Or lazy entities, okay? If I can walk or run, what am I going to do? Most people are going to walk, right? Okay? If you can sit up or lay down, what are most people going to do? Lay down, right? If you can stand or sit, what's most people going to do? Sit, okay? So if I told you to get the answer, okay, and you got 17 over 7, is that lazy compared to now taking my calculator out of my book bag, turn it on, hit 17, divide by 7, get an answer, and writing that down? Yeah. So this is the best answer and the laziest. Okay? So I'm going to kind of try to keep us lazy. All right. Let's do this one. A couple things you can do here. So what do you want to do in this one first? With the end all goal of isolating variable on one side. Okay, you want to distribute. I think that's the number one answer that people give. Distribute. So I'm going to get 5 times 2, which is 10, and then 5 times, so it gives me negative 5g, right? Equals 0. One thing that gets people confused or they struggle with, when they're working with an equation and 0 shows up on one of the sides, like they think that they connect 0 with like non-existing, okay? They say, well, if it's 0, then there shouldn't even be a side over there. Does that make sense? 0 is a number. So if you do some work and you get 0 as a result, make sure you write it down, okay? I'll give an example of that here in a little bit. What do you want to do now? Subtract 10? Okay, so you get negative, so let's go that route. You get negative 5g equals negative 10, right? Then what are you going to do? Divide by negative 5? What's a negative divided by a negative? Positive, right? So, some of you are saying this is garbage. What would you have done here instead? Added 5g to both sides, right? Gives you that. And then you would divide both sides by 5, and you get 2 is equal to g, right? Okay, so if we're in the business of saving pencil lead, then why did we distribute at the beginning? If you said you wanted to save time, why distribute at the beginning? Because when we have a set of parentheses, and this is something that is very important, that set of parentheses, we can view that as one object. Does that make sense? And that's what they want us. It's a grouping symbol. So we have 5 times something, right? Okay. Well, if I have 5 times something, that's multiplication, right? How do I undo multiplication? Divide. So so when I know what g is, this is a number. So I've got 5 times a number equals 0, right? Can I divide both sides in this image right here? Can I divide both sides by 5? Well, think about this. Those will cancel, right? Because you got something divided, 5 times 2 minus g minus that 5, so those will cancel. What's 0 divided by 5? It's 0. Okay? You can take $0 and divide it 5 ways and know what every single person's getting. You're getting 0, right? I can take 0 and divide it by things. Okay? Think about it. So now I get 2 minus G, right? Now what can I do? Add G to both sides. Do I still get G to be 2? So the idea, though, is that we've got multiple approaches, right? Multiple ways of doing this problem or problems like this. And when I said earlier that when you do work and you get 0 as a result, a lot of people, I'll get people that like 0 divided by 5, or maybe they have like maybe they do subtraction and then they make one side 0. They think that disappears completely, and then they get 2 minus G and they don't know what to do. Okay, if you get 0 as a result from something, write it down. Okay, especially if it's the only thing left over on one of the sides. What about this one? What did we do first last time? Distributes. I think that's the best thing to do here. Okay. So what is the number you're going to distribute? This is where this. So this is why we talk about order of operations the other day. Order of operations are going to dictate what you need to do first on the left-hand side of an equation, and then you do it on the right-hand side of the equation. And then once you've exhausted all your order of operations, then you can go through and start trying to isolate variables. So are there parentheses? And there are, right? But is there anything I can do inside those? Is there any combining of like terms? And that's really what we're talking about here, is that PEMDAS is going to allow us to combine like terms. Okay? But we have to be able to generate what those like terms are going to look like. Okay? So no parentheses I can do anything with. There's no exponents. Is there any multiplication being expressed up there? That thing right there, right? So x plus 4. And what is it getting multiplied by? Negative 3. Remember the first name, last name idea. When I take a number, I've always got to use the sign that goes with it. So I'm going to take the 2 I'm not going to deal with, right? So the 2 just gets written down in the next line. But now I'm going to take the negative 3 and multiply it by x. What's that give me? Negative 3x. And then we'll take the negative 3 and multiply it by 4. What's that give me? Negative 12, right? Equals then 8. So the reason we have to go through that order of operation process, okay, or sometimes you'll hear me say, what does the math on the left-hand side tell me to do? What is that multiplication with the negative 3 and the x plus 4, what is that implying I should do? I need to multiply that out, because now do you see that inside this green phrase, come on, inside this green phrase here, were hidden like terms. Does that make sense? And we have to be able to get those pulled out. So what's that going to, what's 2 minus 12 going to give me? Say again? Combine them, so what's 2 minus 12 then? Negative 10? Okay. Or you can, so because we understand our commutative property, could I have rewritten it as negative 12 plus 2, because that's a positive 2 out here in front? Plus 2. So you can do that kind of thing. Okay, but I'm just looking at combining like terms, so I like to highlight my terms that are like, and then do the math that's there. So we got negative 10, and then minus 3x equals 8. All right, so in the next step, what do you want to do? I think that makes most sense. It's not the only thing you could do, but I think that makes most sense. So plus 10, so negative 3x equals 18. Now what? Divide by negative 3. So what is a positive divided by a negative? Negative. An odd number of negatives always gives you a negative. And what's 18 divided by 3 then? Negative 6. Okay. Now, man, I always like to go back, guys, and think about alternative routes that we could have taken. Okay. Could we have done this? Negative 10 minus 3x equals 8. I know some people don't like having a negative variable. Did anybody think about adding 3x and adding 3x and getting the negative 10 equals 8 plus 3x? Then subtract 8, get negative 18 equals 3x. And get something like that? That kind of makes sense? Does this smell like garlic bread in here? That's weird. Yeah. No, but it smells delicious over here. Why don't you guys take a minute and do that one on your own? What'd you do first? Okay. So distribute 6 in and then minus 24? Now what? Is there a wrong thing to do next when I ask that question? Nope. And now what? But we got 8 over here on the left. It's up to you and your notation. But what if I would have done this? I get people to do this a lot, and this is going back to the idea that if I subtract 3 in here and 3 in there, can I do that? Okay, but what do I get on the right-hand side? Nothing. And make sure when you say nothing, you correlate that to the number 0. Okay, because my fear is that we get nothing and then we don't write anything. Okay, and we don't know what to do from there. Okay, but we got to have always, when we have an equation, there is nothing, absolutely nothing, that can get rid of your equal sign. So I get 3 n equals 24, divide by 3 again, n equals 8. This one? No, we got 8 minutes yet. Yeah. We get out at 40. We got 3 minutes.